This video will demonstrate how to solve equations through the use of common base. When we're talking about common base, we're looking at the 5 and 25. In order to keep going forward, they have to be the same. So our goal is to make those bases the same. In this case, I'm aiming for a base of 5 because 25 can be changed to 5 squared, and everything else is staying the same. So I'm just going to copy them. When you have power to a power, you have to distribute. So this 2 will distribute to 3x, and this 2 will also multiply to that negative 2. Two times 3x is 6x, and 2 times negative 2 is negative 4. As you can see, we finally achieve a common base of 5. Since they're already the same, we can just focus on solely getting the exponents being the same as well. So right now we ignore the base of 5 and focus on the exponent of x and the exponent of 6x minus 4 being the same. Now let's just solve for x. Now we have x on both sides, so let's move one of them. I'll decide to move 6x by subtracting 6x to get negative 5x on the left side. And then the right side, we are left with negative 4. To get x by itself, we divide by negative 5. So x equals negative 4 divided by negative 5, which simplifies to 4 over 5. And we are done with number 1. On number 2, we're going to do the same concept. But in this example right here, there is no way I can change this by itself and get a base of 8, or change that to get a base 16. Therefore, I'm going to change both bases to achieve my goal. As an example, I'm going to change 16. 16 is the same thing as 2 to the power of 4, and everything else stays the same. Same thing for number 8. I can change that to a base of 2 to the power of 3 is 8. Now when you have this at the bottom of the denominator, you can move it up. But when you move it up, the exponent here will change signs. It is positive 4, so now it will be negative 4. And everything else stays exactly the same. Anything times 1 is the same thing, so we can simplify that to just 2 to the power of negative 4, and we have x plus 2 still as the exponent. And this problem is now similar to what we were doing on the first example. We have negative 4 as an exponent to the power of x plus 2, so we have to multiply these in order to simplify it. Negative 4 times x is negative 4x. Negative 4 times 2 is negative 8. And we still have the rest of the problem. We have achieved our common goal once more. The bases are the same. We can now ignore the 2's and focus on the exponents of negative x4 minus 8 and positive 3. We're now just going to solve for x. By adding 8 on both sides, I end up with negative 4x equals 5. Oh, nope. 3 plus 8 is 11. And to get x by itself, we divide by negative 4. So we end up with negative 11 divided by 4. On the third example, there's a radical, the square root symbol. So that just makes it a little bit more complicated because now fractions are guaranteed to be part of our problem. So I'm looking at the base of 8 and the base of 4. And once again, in order to achieve a common base, I need to change both of them. So first thing I'm going to do is change 8 to 2 cubed. Next thing I'm going to do is change 4 to 2 square. the exponent of x minus 3 is still there. Now I'm going to change the power in the root here and make it into 1 over 2 to the power of 3 divided by 2. It's a power over root. That's a power of 3 and a square root. The invisible 2 is implied there. So that's 3 over 2. Over here, you can go ahead and distribute that 2 for the same reasons as example 1 and 2. That will become 2 to the power of 2x minus 6. Just like before, I'm going to move it up. So the exponent becomes negative, because it was positive before, it now changed to negative. And technically it's a times 1, but anything times 1 is the same, so it stays as that. I'm going to go ahead and copy the right side, which is 2 to the power of 2x minus 6. We have achieved our goal of common base once more. So now we're going to ignore the base and focus on the exponents of negative 3 over 2 equals 2x minus 6. Now to solve for x, I have to add 6 on both sides. And I end up with this equation. And in order to add, we need a common denominator. So in order to get a common denominator, I need to change 6 to 6 over 1, which have different denominators. So I need to multiply this 1 by 2 so that we have a common denominator. Now we have negative 3 over 2 plus 6 times 2 is 12, and 2 times 1 is 2. As you can see, we now have a common denominator. Once we have a common denominator, we can finally add these two fractions. So negative 3 plus 12 is positive 9. And the denominator stays the same. You need common denominator whenever you add or subtract fractions. And the 2x goes back down. And to get x by itself, we have to divide it by 2. So we need to divide 9 over 2 divided by 2. Whenever you're dividing and a fraction is involved, all you have to do is copy the top, the numerator, which is 9 over 2. And instead of dividing, that divide is now a multiplication. And instead of multiplying, instead of this 2 here at the bottom, we have to look at it as a fraction, which is 2 over 1. We have to do the reciprocal. So the 1 goes on top and 2 goes to the bottom. And we now have 9 over 2 times 1 over 2 instead of 9 over 2 divided by 2. They're exactly the same thing. 2 divided by 2 is 1, so we're left with 1x. Now we multiply straight across. We do not need a common denominator, even though they are common. 9 times 1 is 9, and 2 times 2 is 4, and we have solved for